Let's look at the sum from n equals 1 to infinity, n over n plus 1 times negative 2x to the n minus 1. We're going to look at the n plus first term first, and then we're going to divide that by the nth term. So for every n, we're going to replace it with n plus 1. So we're going to take the absolute value, then the limit as n approaches infinity. We want this thing to be less than 1. So we're going to eliminate the negative 2x to the n minus 1 and negative 2x to the n and have a factor of negative 2x. And now we can multiply the n plus 1 times n plus 1 to get n plus 1 squared. And then we're going to divide it by the product of n times n plus 2. Now this negative 2x, if we take the absolute value, that cancels out the negative, and we can pull it out in front. So that would just be the absolute value of 2x times the limit as n approaches infinity, the absolute value of this. Want this to be less than 1. The degree of the top is 2, the degree of the bottom is 2, so we know that the limit's going to go to 1. So we have the absolute value 2x times 1 is less than 1. Divide both sides by 2 and get that the absolute value of x is less than 1/2. So that means that x is between negative 1/2 and positive 1/2. So that leaves us to test the endpoints. So if x is negative 1/2, we'll have n over n plus 1. Then negative 2 times negative 1/2 is just 1, and that'll be to the n minus 1 power. So that's just 1, which is just n over n plus 1. And this diverges because the limit goes to 1. So we do not want to include negative 1/2. If we have positive 1/2, we have n over n plus 1. And then negative 2 times 1/2 is negative 1 to the n minus 1. So here this is an alternating series. We want to make sure it's decreasing, going to 0, and positive. So obviously n over n plus 1 is decreasing since the denominator is bigger. The limit does not go to 0, but it is positive. So this does not meet all three criteria, so we do not want to include 1/2. So the answer is from negative 1/2 to positive 1/2. Last one, we have the sum from n equals 0 to infinity, x to the 3n plus 1 over 3n plus 1 factorial. We're going to look at the n plus first term. So we're going to add 1 to m to n. So instead of 3n, we're going to have 3 times n plus 1, and then plus 1 over 3 times n plus 1, and then we're going to add 1 factorial. That's going to be over x to 3n plus 1 over 3n plus 1 factorial. So we're going to look at this limit as n approaches infinity. We want this thing to be less than 1. So we're going to distribute out this 3. We'll have 3n plus 3. We'll add the 3 with a 1 to get 4. And then same thing here. It's 3n plus 4 factorial. And that's just going to be over x to the 3n plus 1 all over 3n plus 1 factorial. And we want to make sure we take the absolute value of this thing, although it doesn't really matter yet. So yeah, we can multiply the top and the bottom, and that's just going to be x to 3n plus 4 times 3n plus 1 factorial. Then we'll multiply these middle two, and we're going to make sure that x goes first. And then we'll have the absolute value, and then the limit as n approaches infinity, being less than 1. We can cancel out these with, and then we'll have x cubed left over. And for the denominator, actually, we can cancel these out, and we'll have 3n plus 4 times 3n plus 3 times 3n plus 2. This x cubed will come out in front. So the limit as n approaches infinity, 1 over this product. So this is roughly 27, 1 over 27 n cubed, and clearly that goes to 0. So no matter what x is here, it's always going to be less than 1. Because you're going to have 0 times x cubed, that's 0, no matter what x is. So this converges always. And the radius of convergence is infinity, so that means x will have to be between negative infinity and positive infinity. And obviously it doesn't make sense to include the endpoints.